All right, so who remembers what the area of a circle formula is? Caleb. Good. A equals pi r squared. And that's the area of a whole circle. Today what we're going to look at is the area of a sector, so part of a circle, and also the area of a segment, which is also part of a circle. So a sector is like if you had a piece of pie or a piece of pizza, you'd find the area of just that piece instead of the whole thing. So the formula will be similar to yesterday's. Now, I abbreviate this sec A for sector area. I don't use SA because you'll see that the next one would also be SA, so you have to kind of distinguish. So sector area will be equal to the measure of the arc divided by 360 times pi r squared. So same formula as yesterday, except we're multiplying by the area instead of the circumference. So that's going to give me a portion of the area of the circle. Now the last piece is called the segment area. So first of all, you should see what the segment is in a circle. You can think of it like the crust of pizza or the crust of a piece of pie. So this is called a chord. It is the area that is outside of the chord but inside of the circle. So to find this, what we'll do is we'll find the whole sector. We'll find the area of a triangle that's formed by the radii, and then you'll subtract them. And that will get you the outside part. So the formula for the segment area is actually, we'll call that seg A for short, is to take the sector area, which is the area of like the whole piece of pizza, for example. We'll subtract the area of the triangle, which would be like the cheese and sauce part of the pizza. We'll be left with just the crust, the outside part. Now, if you want a more specific formula for this, this is the one I suggest memorizing. You could actually take and plug in that sector area is arc divided by 360 times pi r squared. That was what we learned right above. What's the area of a triangle? 1/2, they say. So what can make these a little bit hard is that sometimes you don't know the base and the height. So you might have to use trig or special right triangles to find it. All right, on the front, all sectors. Actually, regular circles first. How much more pizza is in a 12-inch diameter pizza than a 10-inch diameter pizza? So this one you have to think about the fact that you're talking about the whole pizza, which is the area. Area is pi r squared. So what would the diameters of each of the pizzas be? What would the radius be if we know the diameter is 12? 6 and 5. So we'll find the area of each. That would be incorrect. It would be 11 pi. Sorry, I was kidding. 11 pi. So when you multiply 11 times pi, it would be approximately you can use the pi key, or you could use 3.14. We'll get 34.6. They don't tell us what to round to. If you leave it in terms of pi, that's fine. Because they didn't tell us what to do. But this will be square inches. But just make sure you leave the pi there, because it is making the number 3.14 times larger. All right, the rest of them are now sector areas. So sometimes you'll be given the measure of the arc. Sometimes you'll have to problem solve to find out how big the arc is before using the formula. But we will be looking at our shaded sector, and the first two ask us to leave in terms of pi. So sector area is our arc divided by 360 times pi r squared. Plug in your numbers. And then you can type this all in your calculator, just omitting the pi key. Remember, and some of you might want to do a 1 underneath. Let's struggle with the fractions. So we really just need to do 72 times 20 squared, which gets me 28,800. Then I'll divide that by 360, and I'll get 80 pi. Again, sector area is area, so it's square units. The next one, what do I plug in for the measure of the arc?
475.
How many degrees is the arc? 270. 270 out of 360 will get you 0.75 if you prefer. Times pi times the radius squared. So just make sure you don't find the area of the white space. You want to find it of the shaded region. We should get 12 pi square feet. All right, the next two I'd like you to try on your own. These tell you to actually plug in pi because the directions say use 3.14 for pi. I'm going to put or use the pi key and round to the nearest hundredth for both of these. So see if you can solve both of those. Make sure you don't plug in 45 because you'd be finding the area you don't want. You could then subtract that from the area of the whole circle if you really desire to, but it's a little faster. All right, on the back we're going to look at the segment, which the first one will be really easy because it's a right triangle. So remember, to find the area of a segment, you will take the area of the sector, which is the whole region, and you'll subtract the area of a triangle. So for the area of a sector, we'll do arc divided by 360. So since this is 90, this is 90. Some of you will just use 1/4 because you know that that's 1/4 of the circle, 2 times pi times the radius squared. Minus, what's the area of a triangle? 1/2 base height. What is the base and the height of the triangle in our picture? Looks like we only know the base. 8 and 8. This is a radius. Remember, a radius could be drawn anywhere and it would still be 8 feet long. So since this is also a radius, we would have 1/2 times 8 times 8. Now it does tell us to actually round this at the end and use the pi key. If you want, you can type this whole thing in your calculator as it is using the parentheses. If you want to do piece by piece, you can. You just have to actually write out all your decimals. So the first part, we would end up getting 90 times 64 divided by 360. So this is 16 pi if you wanted to leave it in terms of pi, minus 32. If they ever ask you to leave something like this in terms of pi, you cannot combine these because they're not like terms. So that would be your answer. You would just put feet squared. But they want us to round this. So now I'll take 16 pi minus 32 and we'll get 18.3. And that would be square feet. This one said nearest 10. So just following, I know they switched the directions on us. Now the next one gets harder because it's not a right triangle. So same process to find this segment area. We're going to find the sector area and subtract the area of a triangle. The sector area should be easy. The arc is 60 divided by 360 times pi. The radius is 5 squared. That's easy. The triangle is the hard part. We don't know the base and we don't know the height. So I'm going to redraw this triangle. You know that this side is 5. You would also know that this side is 5 because of our radius. Now technically you do know the base. Because if this is 60 and it's isosceles triangle, it actually is an equilateral. So you would know the whole, it's a 5, 5, and 5. But if you didn't realize that, you can bisect the top angle into 30 and 30. And then we would realize that this is 60 and 60. We can use special right triangles. So across from our 30 is our S, across from our 60 is our S root 3, and across from our 90 is our 2S. What could you do instead of special right triangles? find out. That is a special right triangle. What could you do instead of using a 3690? So Katoa, if you wanted. All right, but 5 equals 2s, therefore s equals 2.5. So you would get that this is 2.5, that's 2.5, add those together. The whole base of the triangle is 5, so you see it's equilateral. And then the height would be s root 3, which would be 2.5 root 3. So that goes into our 1/2 base height formula. Make sure you do use 5 as your base, not 2.5. So it's the whole base. And then we need to type this all in our calculator. $60 divided by 360 times pi and times 25 gets me 13.0899 ... I'm not writing that all out on the board, but keep it in. Nope, that's just the sector area. Now I need to subtract this. So I'm actually just going to type that all in my calculator. So I'm going to press minus. I'm going to put a parenthesis, and then I'm going to type that whole thing in my calculator so that I don't have to write all the decimals out again. Final answer should be 2.26, which will follow the same directions from above. So that'd be 2.3. And we don't have any units, so I'll just put units squared. That's the hardest the segment gets, is when you have to find the base height. Problems where we have to find the radius or the diameter. Now, those of you that work ahead, for number 8, I'm changing the question. So for those of you that work ahead, number 8 is going to change. I'm going to jot that down. I'll go back. Yeah, 29.25 pi centimeters squared. Because I wanted one in terms of pi and one not in terms of pi. Reagan, did you get it?
I'm still getting -8.5.
They want us to find the radius. Avery, are you done solving this question?
What?
Are you done solving this question?
Yes. We got 9.
Can you please be quiet while I'm teaching?
Yes.
Thank you. 9 is not correct for this problem. Maybe correct for the next question, or part of the next question, but not this one. So we're plugging 37.68 in for sector area. What are we plugging in for the arc? 120, good. Don't plug in 240, that's the part of the arc you don't want. So subtract that from 360 to get 120. All right, now, if 120 divided by 360 is a nice decimal, like stops, you can write out that decimal, but it's not. Okay, so you could reduce this if you'd like, but I'm probably just going to leave it as is, but it would reduce to be 1/3. So to solve for the radius, you need to undo multiplication with division. But instead of dividing by a fraction, what can we do to both sides? Multiply by the reciprocal. And I'm just going to leave the pi there for now. Okay, so on this side, I will put the 37.68 over 1, and I'll multiply, calculator's bugging. Multiply the 360 times 37.68. And then the denominator, 120 times 1 is 120. Equals pi radius squared. Before you can square root, you do have to divide by pi. You could divide these if you want. You'll get a decimal. I don't think it's terminating though. Is it? Oh, it is. So let's do that. If it stops, write it out. Even if it doesn't stop, write out all the decimals if you prefer. So now we have to undo multiplication with division. And so you don't have to write out a bunch of decimals, I'm going to leave the pi in the problem until I type it in my calculator, because now I'm going to square root both sides to undo a square. And then you can type this into your calculator without having to store any answers. So we'll take the square root of 113.04 divided by 5. We should get 5.998, which would round to be 6.0. Regular feet. Okay, now number 8, I've decided to change it so that it's not a decimal, that it's actually in terms of pi. That way we can try one of each type of problem. So why don't you guys give that one a try while I'm passing out your homework, and then we'll go over it at the board. Change the area to 29.25 pi centimeters squared. So get rid of the 91. I've made it in terms of pi. That way we have one of each type.